Morning, everyone. I hope you had a very safe weekend. Um, I hope you guys keep staying safe. Right. So this week we're going to do some more practice on fundamental principles of counting. We're going to tackle different scenarios, but the procedures of the count are still the same. Okay. But before we actually go over um, this lesson, we have to go over the PGCPS safety guidelines. All right, so take note of this protocol. Please be reminded that the PGCPS administrative procedures regarding appropriate use of technology, social media, and email continue to apply to our online instruction. In addition, this session may not be recorded without the instructor's consent. So take note of this statement. This, of course, does not apply to us because this session is already recorded. So there is no use for you guys to re-record a recorded one. Okay, we will understand it as the recording cannot be shared without the instructor's consent, which is me, right? My consent. Anyways, if you would like to read more, okay, of the applicable procedures, it is provided in the Student Rights and Responsibilities Handbook. Thank you for your cooperation. So if you would like to read more on this, the Student Rights and Responsibilities Handbook is definitely accessible at the online PGCPS portal. So you can definitely go over there, find the Student Rights and Responsibilities Handbook, and then browse over to the appropriate section. Or you can access the Student's Handbook also from the Google Classroom. I believe I put it up there all the way in the beginning. So you may access it there as well. All right. Now that we have made clear and are reminded of what the distance learning safety protocols are, we can definitely now go over with our lesson for the week, which is more practice in counting. Also, we're going to be introducing a new mathematical operator here, which is referred to as factorials. So factorials is definitely an important mathematical operator. It's used a lot in statistics, but it definitely has its uses observed also in calculus, particularly in more advanced parts, which include Maclaurin series and Taylor's series. But we will not go there, of course. We just focus on what factorials really are, how are they used, and when are they used. Okay, so before we go to the lesson, let's go over the objectives. So the objectives here is for you to be able to practice more on the fundamental principles of counting techniques, and also to be able to define and use factorials to solve word problems. So this would be our objectives for the week. Okay, now that we've gone over that, let's do a review on the fundamental principle of counting. So take note that the fundamental principle of counting states that if you're given two events, A and B, the number of ways that events A and B can happen together, which is signified by this symbol right here, is simply the product of the number of ways that event A happens multiplied with the number of ways event B happens. So if two events are to happen together either simultaneously or one after the other, you need to multiply the number of ways each event happens. If the number of ways event A happens is 6 ways, and the number of ways that event B happens is 5 ways, Therefore, the total number of ways that event A and B happens would just be 6 times 5, which is 30. Now, if we're considering the number of ways events A or B could happen, now when you talk about OR here, it's an exclusive OR, which means that the events happen one or the other. If event A happens, that effectively bars event B from happening and vice versa. So only one of the two events is expected to happen, either A or B, and not both of them. The total number of ways that event A or B could happen would simply be the sum of the number of events A happens plus the number of ways that event B happens. So using the same set of numbers, if event A happens 6 ways and event B happens in 5 ways, then you only have 11 possible ways for event A or B to happen. So take note of these two operations. One is multiplication, the other is addition. Right? So pretty much easy enough to remember, as there are only two possible operations that were going to be used, at least in the earlier parts. Okay, let's now go to the first example. So the first example is the rules on how Maryland issues standard passenger license plates. So I did look this up, and I found out that Maryland issues passenger license plates which are made up of 6 characters. The first, fifth, and sixth are numbers, while the second, third, and fourth characters are letters. Right? That's easy enough to remember. The first and the last 2 are numbers. The middle 3 are letters. Right? Now, besides that particular format, there are also restrictions on the letters and the numbers that are to be used for the license plates. First, for the letters I, O, Q, and U cannot be used. In reality, the letters I, O, Q, and U can still be used for passenger license plates. However, they need to be personalized passenger license plates. In this particular case, we're not going to consider personalized passenger license plates. We're only going to consider standard issue Maryland passenger license plates. Right? With the numbers, the only exception would be for the first number. Right? The first number could not be a 0. All right. Okay. So this format and those 2 initial restrictions will always be applicable for whatever question comes next. So let's see what type of questions follow so we can actually start answering them. First, there are no restrictions. Now, what this one means is that there are no other restrictions besides the first 2 here that were mentioned, following the format that was mentioned earlier. So effectively, what it's asking is, how many unique Maryland standard issued passenger license plates are available? Letter B, right? How many of those plates, right, will be such that all the letters and numbers are the same? So an example of this would be 1 followed by 3 A's and then followed by another 2 1s. 1 triple A 11. So this would be a Maryland plate wherein the letters and the numbers are the same. Not the letters and the numbers, but each number with itself, each number with themselves, and each letters with themselves. Letter C, right? Definitely the way it was written is quite long. So I'm guessing this is a more complicated way or more complicated scenario to be counting. It says first, no characters are to be repeated. Aha. So here, we will definitely observe a decreasing number of a decreasing set of numbers as we go over to later choices. Okay. Also the letters used, all right, and the numbers used has a particular combination. The first one is it will be consonants and even, and the other one would be vowels and odd. So thus, the plates should look like all the letters are consonants with all the numbers being even, and also all the letters are vowels while the numbers are odd. So it's either constant and even or vowels and odd, right? Now, since consonants and vowels are different letters, definitely if it's a consonant, it cannot be a vowel, then these two events are exclusive. So what we're going to do to be able to solve C is actually to figure out two cases and then add the total number of ways that consonants and even plates have plus the number of odd and vowel plates are. Once we add them, we actually answer letter C. All right. Now, if you would like to work on this on your own, you may pause the video to give you more time. And then when you are ready, you may unpause it and see the big reveal and also the solution on how we actually came up with the answers. Right? I think this is enough time for you guys to actually pause and unpause the video. So we're now going to go over the answers and the solution. All right. So the first part of the solution begins here. The one written in red ink. I noticed that a lot of you guys actually use letters to designate positions. So I would be using the same technique. 6 characters in the Maryland license plate format. So I'm going to use 6 letters to designate that format. A, B, C, D, E, F. Where A would be the very first character out of the 6 and F would be the last character. So A, E, and F stands for numbers, while B, C, and D stand for letters. Okay. Right. So now let's go over with the possible number of choices for each of this position. So to make it more organized, I actually tabulated it. But in your solution, you don't need to actually tabulate. As long as if you put in only numbers, then I will not understand how you computed it. I will assume that it's an all or nothing approach. But if you actually break it down of what numbers you multiply, I would be able to figure out your thinking and give you more meaningful feedback. Aha. All right. So the first question is, what if there are no other restrictions besides the ones already mentioned here? Right. So as I mentioned, we're going to tabulate positions A all the way to F and also indicate the number of choices for each particular position. Now note that A, E, and F are number positions, B, C, and D are letter positions. Let's start with letter A. So for position A, which is a number position, we have 10 possible digits to choose from, 0 all the way to 9. However, if we look at restriction 2, it says here, the first character, which is a number, cannot be 0. So for position A, we cannot choose 10 characters sorry, there was some technical difficulties there. As I mentioned, for position A, since you cannot use 0, you only have 9 possible digits to choose from 1 all the way to 9. Now, when you go to positions E and F, which are also number positions, there are no other restrictions on the digits we can choose. So therefore, we actually have all 10 possible digits ready to be chosen for those two particular positions. Okay, so that takes care of the numbers. Now let's go with the letters. Positions B, C, and D. Now take note, we're going to be using, of course, letters from the English alphabet. So you should be aware that we have actually 26 letters in the English alphabet. So can we use all 26 letters in the plates? Actually, no. Because if you look closely in restriction 1, there are 4 letters that cannot be used. I, O, Q, and U. So if we had 26 letters to begin with, and we take 4 of them out, that only gives us 22 possible letters to work with. Okay, so position B would have 22 letters to choose from. So is position C and position D. All right, so now we actually have all the possible choices for all possible positions. And because the Maryland plates is made up of 6 characters, then we need all 6 of them to actually determine the total number of plates that we have. So since we need all of them, they have to happen all together. We need to multiply all of these digits together. So we have 9 times 22 times 22 times 22 times 10 times 10, which gives us 9,583,200. So what this means is that there is actually 9,583,200 unique standard Maryland issued passenger license plates. So the question is, what if you were the 9,583,200 first driver to ask for a plates? Does that mean they've run out? Actually, no. What's going to happen is, once all the possible plates have been used up, they're actually going to start recycling old plates. Now, take note that this plates, of course, is assigned to a car. So definitely the older cars would definitely not be active anymore. So therefore, their plates can be recycled to be issued to new drivers. And this is how it will work. So even though there's actually a limit on the unique number of plates that can be issued at any particular state, there should be no problem in issuing plates. Right? So as long as we don't actually keep changing cars at a faster rate, then we can actually recycle numbers. But if that case happens, then we just have to change the way we assign plate numbers. All right. Okay. So now we go to B. Right. So for B, it states that the numbers and letters should be the same. In short, we only need to use one type of number and only one type of letter. Right? So how are we going to do this? Okay. So let's start with the numbers first. Position A. So for position A, we only have 9 possible digits to choose from because we cannot choose 0. So assuming that you choose one number out of those 9 digits, let's say you chose 5. By choosing 5, right, so your plate begins with a 5, then 3 letters, then 2 numbers. By choosing 5, you have already restricted the number of choices you have for positions E and F. Take note, the numbers need to be the same. So whatever number you choose in position A should be the same number you choose for position E and F. That's why position E and F can only have one possible choice. Whatever you chose for position A. The same logic applies for the letters. So starting from position B, you have 22 possible letters to choose from. But once you've chosen a letter, that already narrows your choice for positions C and D. And again, because you need all 6 characters to create a plate, then you just need to multiply all 6 numbers here, and you will get the total number of plates you have with that particular property. So 9 times 22 times 1 times 1 times 1, that is simply just 9 times 22, which would be about 198. Aha, there we go, 198. All right, now we are ready for the difficult one. So in this case, right, in this case, there should be no repeated characters. All right, and then also the letter and number combination. So the letter number combination is, if you're using consonants, then the numbers you choose need to be even. While if you choose vowels, then the numbers you need to use are odd. Okay. All right, so first, the characters cannot repeat. Okay, so we should see a decreasing particular set of numbers as we go along at later positions. And then for the combination of letter and numbers, if you go with consonants, the numbers need to be even. And if you go with odd numbers, the letters have to be vowels. All right. Okay. So in this case, we're going to split our count into 2. We're going to consider 2 cases. One case would be the set of plates, which are consonants and even numbers. The other case would be the one made up of vowels and odd numbers. Right? So again, we tally the set of possible choice of digits or letters we have for each particular position. So this one, the first case is consonant and even. So for position A, you have 5 possible even digits, but since you cannot use 0 here, that means you only have 4 possible choices: 2, 4, 6, or 8. Right? That's why it's 4 here. Now, as you go to position E, which is the next number position, you should have 1 less choice. So you should only have 3 possible even numbers to choose from. However, take note that in position E, you can now choose also 0, because 0 is not only available for use for position A, but for position E and F, it is actually available. So even though you should have 1 less digit to choose from for position E, with the addition of 0, that makes you 4 possible digits to choose from. Okay? And then finally for F, after choosing 1 digit for position A and 1 digit for position E, you will have only 3 possible even digits to choose from. So that is our number choices for positions A, E, and F. Now let's go with the letters. Okay, note that we have 26 letters in the alphabet, English alphabet. 5 of them are vowels. The vowels are A, E, I, O, and U. I will assume that you guys actually know this by heart. Thus, if 5 of them are vowels, then the other 21 should be the consonants, right? Everything else that are not vowels. Okay, so does that mean we have 21 choices for position B? Actually, no. If you look back at the initial conditions, there are 4 letters that cannot be used: I, O, Q, and U. Among these 4 letters which cannot be used, Q is actually a consonant. It's actually the only consonant that you can't use. So if you had 21 consonants, but you can't use Q, that means you can only use 20 possible consonants. Aha, all right? So position B has only 20 possible consonant choices. Now, as you go to C, you actually lose one consonant because you already chose one consonant for position B. And as you go to D, you lose another consonant choice. Thus, the total number of consonants and even number plates, which have non-repeated characters, will simply be the product of these 6 numbers. So whatever their product is, that is the total number of plates in case 1. Now let's go to case 2, where the plates are made up of vowels and odd numbers. So for position A, we have odd number position here. So in the first digit, we actually have 5 possible digits to choose from. That is 1, 3, 5, 7, and 9. Now, as you go to position E, you lose 1 odd digit to choose. The number of odd digits you can choose now becomes only 4 because you've already chosen 1 for position A. Now, as you go to position F, you lose another one of those those odd number digits you can choose. Thus, it only becomes 3. Okay. Now we've figured out how the numbers follow for case 2. Now let's go with the letters, which are vowels. Now, note that in the 4 letters that have been accepted, 3 of them are actually vowels, O, I, and U. All right? Since the 5 letters are A, E, I, O, and U, and you can't use I, O, and U, then the only letters or the only vowels you can choose are actually A and E. So for position B, you only have 2 possible vowels to choose from. So whatever letter you choose for position B, the other letter has to be chosen for position C, which means that you actually have no more vowels left at position D because you only had 2 to begin with. Thus, the total number of plates that would be made up of all vowels and all odd numbers, which have non-repeated characters, is actually 0 because you actually have 0 possible choices for position D. Thus, the total number of plates that satisfies question C is only the answer for case 1. So if we multiply the 6 numbers together, 4 times 20 times 19 times 18 times 4 times 3, we get 328,320. Right? So these are the only possible plates that we have that will satisfy question C because we don't have any plate that would be made up of all vowels and all odd numbers such that all characters are different. We just don't have enough vowels to choose from. If we had, then it would have been easier. All right. Okay. So I hope that has been clear. Now, if you have actually questions with this particular example, remember to actually post your questions in the weekly Google Docs so that I can address them and that you can actually learn how it's done. Now we go to example 2. And example 2 is much, much easier than example 1. Example 2, a small class is made up of 5 male and 5 female students. Suppose the teacher asks the students to line up. How many possible ways can they line up if A, there are no restrictions? So, they can line up any way they want. And letter B, the male students have to be the first 5 people in the line. So the way the line goes is it should be 5 males. So male 1, male 2, male 3, male 4, male 5. Then followed by the next 5 females. Female 1, female 2, female 3, female 4, female 5. All right. So here, pretty much we have 10 possible positions because there are 10 students. There would be like 10 possible positions in the line. So again, we're going to use the letter combinations that we have, right? Which will be from A to J. Okay, but if you would like to try this on your own, you may pause the video, work on it, and then when you are ready, you may unpause the video and then we'll see the big reveal. All right. Okay, I think that should be enough time for you guys to pause and unpause the video if you actually worked it on your own, if you practiced on your own. Let's try now to see what the answers are and how did the solution go. So as I mentioned, we're going to use again the letter position technique that I've seen from the works that you've submitted. So since there are 10 people that we need to arrange here, so we're going to use 10 letters. So it goes from A all the way to J, where A, right, is the person in front of the line, and J would be the person at the back of the line. Okay, so to make it also clear, we're going to tabulate the possible choices we have for each particular position. Okay, so for the first one, there are no restrictions. So for the very first person in the line, position A, you actually have 10 people who can actually line up over there. Okay, so you choose one person there. Now, once that person actually stands in that position, that means you don't have 10 people to choose from on the next position because there's only 9 students left. One student has already been assigned to the very front of the line. So letter B would have one less student to choose from. And this one goes all the way up to J. All right, so this is pretty much the number of student choices you have for each particular position, assuming that you choose the first student first at the top of the line. Okay, so you first begin choosing from the very front. Okay, since you need all 10 of them to be present because you are actually assigning lines. Okay, so you need to multiply all 10 of these numbers. We have 10 times 9 times 8 times 7 times 6 times 5 times 4 all the way to times 1. If we multiply all 10 numbers here, we actually get 3,628,800. So that's how many possible combinations, all right, or arrangements in a line that we actually have for these 10 students that we have, which are made up of 5 males and 5 females. Right? Now, what about for the second condition, wherein the first 5 positions is occupied by males and the next 5 positions are occupied by females? Okay, so notice for positions A to E, right, these are the male students, and positions F to J are the female students. So for position A, since you have to choose a male student there, you only have 5 possible choices, right? Because there are only 5 male students. Now, as you go to position B, all right, your choices decrease because you've already put them in the earlier position. So this goes all the way to E. And from A to E, you've actually arranged already your 5 male students. So after you arrange your 5 male students here, you are now ready for your female students. Okay, so the process is also the same. For position F, or the very first position that a female student would be in, you have 5 possible choices there. As you go to G, your the number of female student choices you have decreases by 1. So you have 4, and this goes all the way to 1 as you get to J. And since you need all of them, all 10 of them, to line up. The total number of arrangements that you will actually have would be the product of these 10 numbers here. So it's pretty much 5 times 4 times 3 times 2 times 5 times 5 times 4 times 3 times 2 times 1. But if we're actually in a hurry, notice that we can actually just multiply this 5 numbers here and then just square them. That definitely saves us a lot of time in punching the numbers in the calculator. So 5 times 4 times 3 times 2 times 1, whatever the answer there is, you square that, you actually get the product for this one. And here is how it goes. All right. So this one definitely allows us to compute for the number of ways of linear arrangements we have, given particular constraints. Okay. Now take note, in the beginning of the lesson, I did talk about factorials, and I did mention that it's going to be at the end. Right? So here are now factorials. Okay. So in the last example, pretty much in question A, so we were supposed to arrange those 10 students. So the way we computed them is because there were 10 of them, and we had to actually use all of them. So we started with 10, then we kept multiplying all the way until we got to 1. Now this process is actually very, very interesting, and they actually introduced a mathematical operation that does the same process, and it is referred to as the factorial. Okay, so the way a factorial works is, given a particular number, if you took its factorial, what you need to do is you have to multiply that number with all other counting numbers less than that until you get to 1. So the next number gets smaller by 1, and this continues all the way until you reach 1. Now take note, factorials only work for counting numbers. These are positive integers. Right? I think it also includes 0, so it should be whole numbers. Instead, that we will actually go over that later. But take note, when we talk about factorial, n here should only be counting numbers. That means you cannot use decimals, you cannot use radicals, you cannot use fractions, you cannot use negative numbers. It has to be a counting number. So something you use to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to maybe 10 million and so on and so forth. Right? You cannot choose something with 1/2, something with 1/3. Okay? So to express as more of a technical equation, all right, a factorial, n, or n factorial, can be defined as n times n minus 1, which means 1 counting number lower, times n minus 2, and you keep multiplying until you reach positive 1. Right? Now this one is convenient. Right? This one is convenient because the earlier example can be answered in terms of factorials. Okay, take note, the first solution was 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is of course 10 factorial. For the second one, we have 2, 5 times 4 times 3 times 2 times 1. That's why we had to square it. But take note that 5 times 4 times 3 times 2 times 1 can actually be expressed as 5 factorial. All right? So here we go now. There are no restrictions, so it can be written as 10 factorial. Male students have to be the first 5 people in the line. 5 factorial times 5 factorial, or pretty much 5 factorial squared. Now, this is the question. Okay, so, Mr. Trezino, now that we know what the factorial stands for, does it make our lives any easier by that? Yes, because it is actually possible to compute for factorial directly. So for those, right, who are aware of their calculators, you should be aware that there are exclamation points, which is the factorial symbol present. Okay, so I'm going to actually go over ways in order to find the factorial symbol. Let's start off with Texas Instruments calculators. So for a Texas Instruments calculator, the factorial can be found in math. I think it's under probability. There we go. Probability. And there you go. Number 4. So if you are into, or if you are using Texas Instruments calculator, you can get into the factorial by first pressing math, then going over to prob, which I guess stands for probability. Thus, all right, if I ask you to compute for what is 10 factorial, so that's 10, then math, go to prob, then go to the factorial. There you go. 3,628,800. Right? Okay, so what about 5 factorial squared? So that is parenthesis, 5, math, go to prob, go to number 4, which is the exclamation mark, the symbol for factorial, close it, and then square. There you go, 14,400. So this is how you do it if you are going to use Texas Instruments calculator. Now, what if you don't have a Texas Instruments calculator? Right. The next option that we actually have would be to use Desmos. All right. So once we go for Desmos, right, let's just wait for it to load. My internet connection is not the fastest. All right. So once it's here, we can now start putting in the factorial. So it's 10. Actually, you can use your keyboard if you have a keyboard. If it was a laptop, so you'd have a keyboard. So you can just use the factorial symbol there. But what if you don't have Desmos on your laptop? Let's say you don't have a laptop. You're only using your phones. That's fine. We can still go with type 10 there, and then you can use this keyboard. And then the factorial should be there. I think it should be under functions. Then I think stats, maybe miscellaneous. I should have that. Let me move this one. There we go. I'm sorry. It should be under the letters. So you click on the letters here. All right. Then you choose this exclamation mark, factorial symbol, solved. Okay. Now, what if you also don't have Desmos? Because let's say during this time you didn't have online access. Well, we have another way of doing this. We can use phones. All right. Let me just access. Right. So the usual phone view for at least an Apple phone looks like this. However, if you turn the phone on its side such that it's longer sideways, So let's say your phone was like this in the beginning, and then you turn it sideways. It's actually going to flip the calculator to like this. There. All right. And if you look closely, you can actually see the factorial symbol right here. So to compute for 10 factorial, you simply press 10 here. I'm sorry, this is just a picture, as it takes a long time for my phone to actually load over here. So if you actually like to compute for the factorial, you press in the number first, then you hit the factorial symbol. Now for Android base, I think you can just switch into a scientific mode. I'm not sure exactly. I don't have, but I'm pretty sure that you'd be able to figure it out. Huh? Wait, I think something went wrong with my screen share. So let's just go back into that screen again. All right, so here we go. So as I mentioned, once you turn the screen over, once you turn your phone over the side, it should access this particular scientific calculator base. Now take note, for this to work on your iPhones, you should enable the change orientation, right? So that when you flip it over, it actually change into this type of orientation. So for Android, I'm pretty sure you can figure out how to get it into its scientific notation or scientific calculator mode. So I hope that today's lesson is actually very helpful, and I hope that you actually improve your counting skills. I'll definitely send in work. You have again until Thursday to complete them. Right. So again, for any questions, definitely post them in the Google Docs, our weekly Google Docs. So nothing else. I hope you guys stay safe, and bye everyone.